arithmetic first. Is 1 plus 2 plus 3 plus 4, is that arithmetic? Yeah, because it has a common difference of how many each time. What are we adding each time? Plus 1, right? Plus 1, plus 1, plus 1. So what we're going to do is we're going to take a look at this and we're going to say, this is trivia that I think everybody should know. What's the sum of the first 10 numbers? 1 plus 2 to 10. Anybody know what that is? Just off the tip of their tongue? Yeah, Nathan knows. 55. Want to see a quick way of figuring it out? Okay, does everybody have the slide? Draw a little bracket connecting those two. What's the sum of those? 11, right? So Olivia, how many of those brackets of 11 am I going to have? 5 of them, yep. So there's a total of 5 11s. Well, what's 5 times 11? 55. That's how you add the first 10 numbers. How about the first 50 numbers? First 50. Let's try my little bracket system here. I'm going to go 1 and 50, 2 and 49, 3 and 48. How many of those do you think there are going to be? How many 51s do you think there's going to be? Take a wild guess. Not 50. 25, because we're pairing first, yeah, so there will be half of those. So, and I don't know what that is. But how about the first 100? What do you think that's going to be? 1 and 100, 2 and 99, 3 and 98. How many 101s are we going to have? 50. So what pattern do you see? You take the total and divide it by 2, and then you add what two together? First one and the last one. There it is. That's the sum formula for that. Oh, wait a minute. That's not right. I have something totally different. This n over 2, well, I got the n over 2, but 2a plus n minus 1 times d, that's not this one. Well, let's do something else first before we get into that. I have the first and the last was 10 plus 1 was 11 times 5 is 50. 101 times 50, do you know what that is equal to? You're going to love it. It's 50-50. The sum of the first 100 numbers, so 1 through 10, the sum is 55. The sum of the first 100 is 50-50. You want to take a guess of the first 1,000 is? Pretty cool. Elizabeth? 500, 500, yep. And how about the first 10,000? It's going to be 5,000, 5,000. No kidding. It works. And it's all because you're multiplying half times 101, 1,001, 10,001. And that's how those sums work. All right, so for this one, if I want to prove what this is, what you can do is you can say, oh, I remember a of n was a plus n minus 1 times d. Remember that? It's up on the board. So we did last week. So you could say this is n over 2, a plus, and then instead of a of n, put a plus n minus 1 times d. And there you got it. N over 2, 2a, n minus 1 times d. And that's the sum formula that you have. So I like to put both of these up. I like both of them. Sum as n over 2, a plus an. Both are good. they'll both work for the sum formula. So you can find those. Would you stop for just a moment? So to prove this with formulas, here's what somebody very clever did. They took the first term, A, the next term, let's say you had 3 plus 5 plus 7. You're taking 3, and you're taking 3 and adding a difference of 2. And then to get 7, you're taking 3 and you're adding 2 differences of 2. Then you're taking 3 and you're adding 3 differences of 2. All the way to the last one, which is n minus 1 times d. Now I want to just do something here quick. I don't know what happened here over the summer, but sometimes these things get moved. And I don't get it. But there we go. Okay, so below this, I'm going to add the sum again. But instead of writing it this way, I'm going to write it in reverse. N minus 1 times d. This next one, n minus 2 times d. And the next one's going to be, and let's see here. I'll write this out quick with the right values. You're going to take this last one and put it first. So we're going to have a plus n minus 1 times d. Then I'm going to take this one and I'm going to put it second. A plus n minus 1 n minus 2 times d. And then I'm going to take the third one, which is a plus n minus 3 times d. And then when you go to the other side, I'm going to take that first one and put it last. I'm going to take the second one and put it last, which was a plus d, right? And then I'm going to do the third one, a plus 2d. And there's dot, dot, dot in between. Well, what happens when I add those all up? I mean, you have sum plus sum in reverse is still 2 sum. And then if you take this clump and this clump and this clump and all of these together, they all add up to one thing. They add up to 2a plus n minus 1 times d. Now this one is also 2a, and d times n minus 2d is still n minus 1d. 2a again, n minus 1d. And so when we do this, there'll be a total of n of these. Well, if you divide by 2, you're going to get the sum is n over 2, 2a, n minus 1 times d. And that's the sum formula. All right, let's practice a couple. Find the sum of the first 15 terms. Find the sum of the first 10 terms. And then this one is moved over just a little bit. This first one, you have a equal to 4. The common difference is 6. And you want to look at n equal 15. Find the sum of the first 15 terms. And then this one, you're going to find a, d, and n, and you're going to find the sum of the first 10 terms. Use that formula of n over 2, 2a, n minus 1 times d. These are the arithmetic type. Now we have one more type to look at, and this is a geometric, has a common ratio, 1, 2, 4, 8, 16. What are we doing each time here to get to the next term? Are we adding the same? No, we're multiplying by 2, aren't we? So if we're doing that, the sum gets a little bit trickier. And so we're going to try to find a formula for that. This one I want you to follow me with, all right? So find this slide. The sum of these, a plus ar squared, ar cubed, this is like 2 plus 4 plus 8. We're multiplying the first term 2 by 2 to get 4 by 2 squared to get 8, and so on, right? So here's what you're going to do. You're going to take the ratio here and multiply it by your sum. So I'm going to take this formula. I'm just going to multiply everything by r. So this a becomes a times r. This ar becomes ar squared. This ar squared becomes ar cubed. So I'm just taking the sum equation here and multiplying by r. And I'm going to subtract these. Why subtract? Because what wonderful thing happens? What happens to everything here, 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 and here? What happens to all that stuff? Cancels all out, and then you're left with the sum of n minus r times the sum of n, and then it's going to be a minus ar to the n. Almost done. Almost, almost, almost. So now I'm going to take out an s sub n, leaving 1 minus r. I'm going to take out an a. I'm going to get 1 minus r to the n. So when I solve for s sub n, I'm going to get a times 1 minus r to the n. And what am I going to divide by? Divide both sides by 1 minus r. 1 minus r. And that's my formula for a geometric series. Okay? And then, you know, the formula, the problems we're going to do next are exactly the same. You know a, r, and n. You can find the sum. But that's the formula. I'm going to write that up on the board. Well, I have it already right there. Let's just do it this way. I'm going to make up just one. One will do it. Let's do that 256 plus 128 plus 64 plus ... I think we went to 1 over 128, something like that. This is going to be, so n equals 16. What's the first term? 256. So that's going to be 256. And what's the common ratio each time? We're doing what each and every time? Half, multiplying by a half. So this will be 1/2. So now you can find the sum of the first 16 terms. That's going to be equal to a times 1 minus r to the n over 1 minus r. So plug those in. Watch it go. 256 times 1 minus 1/2 to the 16. Ooh, that's going to be small. Over 1 minus a half. So that's going to be 256 times, 1 minus 1 over 2 to the 16th, all over 1/2. What do you get for a sum? It's going to be a decimal probably. And we'll let you calculate those out. All right. We'll do one word problem, and then I'll tell you your assignment should be pretty straightforward. Logs of wood are stacked in a pile so that there are 15 logs on the top row, then 16 on the next row down, and 17 and so on, all the way to something, a event. We don't know what. The total is 256. How many rows are there, and how many logs are on the bottom row? Okay, so we're gonna figure this out. Is this arithmetic or geometric? 15, 16, 17. Arithmetic, right? So what's the sum formula for that? Is that number 3 or number 6 on my list up there? For arithmetic, 3. So the sum is n over 2. First one plus last one. We're going to do the 2a plus n minus 1 times the difference. Okay, we said the sum is 256. We don't know how many rows that is, but we do know the first one is 15. We don't know how many rows that is, but we do know what's the difference from one to the next, one row to the next. Common difference? Swooshes? Plus 1, right? So that's simple. So when I work this out, I get, you're probably not surprised, n over 2, 30 plus n minus 1. That's just going to be 29, right? So this is n. I'm going to multiply both sides by 2 and get 512 equal 30 minus 1 is 29n plus n squared. Uh-oh. What does that remind you of? What does that remind you of? Quadratic. Jacob goes, oh no, not quadratic. Yep, and so then you just want to factor that. N, 512. Take your calculators real quick and divide by 2. What do you get? What's 512 over 2? How much? 256. Divide that by 2 again. What do you get? 128, right? Ooh, okay. So, let's divide that by 2 again. And I'm going to get 64. And still not good. Let's divide it by 2 again. 512 by 16, and I'm going to get 32. So will that factor 32 times 16? And is 32, what's 32 minus 16? Oh, that's too big. 64 minus 8. I thought this would factor a little bit better so that you could find out what n is, but that's what you would do, and then you'd know how many rows there are, and then you could find out how many on the bottom row. And I thought it turned out to be a nice number, but maybe not. Yeah. 246. Oh, 46. Oh, right away we got that messed up. Okay, so this is going to be 2, thank you, 592, right? 5, is that right? No, 40, so we just double that. Will be 492. That's better. 492, and I think that's going to factor into nice numbers. All right. So going down to homework, day 2. I want to keep this really Really, really, really simple. We're going to do number 9, number 10, and then I like these two. And I thought I had an arithmetic sum, but I don't see one. Okay, so you're going to do these two and these two, and let's change this number, part A. Would you just change it? Change that one to 5k minus 17. Change this to 5k minus 17. And I'm going to check these tomorrow. Oh, and this one is going to 19. So we're changing this from k equal to 1 to 7 to 1 to 19 of 5k minus 17. You're going to go ahead and do that. You're going to find the sum using the formulas, and then these two word problems. Fantastic. Then tomorrow we'll work on word problems with these all day, and then we'll probably start infinite series on a little bit tomorrow, and then we'll finish it on Wednesday, and we'll probably have a quiz either Wednesday or Thursday. We should be good for the week.